Now let's look at this problem. It's part of the problem 3 we looked at in class. We slightly changed the problem. Now we have this function little f of t. Here is only defined between intervals 0, 1, and 1 and 2 over here. And we want to integrate this function from 0 to x. But x over here is a parameter. We don't know where x is. It's a function between 0 and x. So x can be somewhere over here and can be somewhere over here. Okay. So how can we do that? Now, remember, this is the situation that we can find area, simply use the area, find the integral using the area. So we do the following thing. Okay. So remember that if x is between 0 and x, for example 0.6, then what we have over here is a rectangle. So we actually divide this x into two cases. So we look at the following situation. So when over here, so when x is inside this interval over here, between 0 and 1. Okay. Now, if x is over here, then this one over here, g of x, between 0 and x, is simply a rectangle. Now, if x is over here, then the base is x times the height is 2. So f of t over here, we don't really need to use the fundamental theorem of calculus. So we can simply say this is the base x and times the height, that's 2x. Okay. In fact, we can get the same answer if we find f of t formula first. If we look at the expression for f of t, we have these. First of all, we see that f of t is, again, as we discussed, is piecewise. So if t is between 1 and 0, we have the function exactly constant 2. Okay. Now, how can we find the equation over here? This is supposed to be a straight line. Now we know the slope is 2, and it passes this point when x is 1 and y is 2. So we know the equation for this straight line is the following. Use so-called point-intercept method. We have y minus 2 is equal to the slope, okay, and then x minus 1. But of course here's t, so we really have a t over here. So let's erase this one over here. Okay. So we have over here is t minus 1. Now that means y is equal to 2t minus 2 and then add 2 over here. So really y is equal to 2t. And that's the equation for this line over here. So we have f of t, this function over here, 2t, if t is less than 2 and bigger than or equal to 1. Okay. Now, this part over here, we don't need it if we are calculating this integral. X is between 0 and 1. But if x is not between 0 and 1, but x is between 1 and 2, then we will need a second piece. And then we have the following. Integrate still, this is g of x and it's from 0 to x now. It's the same integral, but now it needs to be evaluated differently. Because x now is over here, so if we look at the area over here beneath the curve, we have this one over here and somewhere over here. So let me draw the one over here. So now it's over here. So this is equal to, according to our observation over here, this is the integral between 0 and 1 because x now is greater than 1. And then we use between 0 and 1, this f of t is 2. So this over here we have 2 and dt. Okay. And then we use the second piece. From 1 to x, we have 2t over here and dt. And of course, the first piece we can see the integral is simply 2 because base times height. And second one, if we wish to use the fundamental theorem of calculus, then this is going to be t squared, and then we plug in x and a 1. Plug x and a 1. So we end up with over here. Let's turn around over here. So this is going to be 2 plus x squared and minus 1. And this is going to be simply x squared plus 1. Squared plus 1. So we end up, again, a piecewise function, g of x over here is equal to, so if x is between 1 and 0, then we have 2x. Okay. And if x is between 2 and 1, then we have x squared plus 1. Okay. If we want to try to graph the function, we remember that we can simply sketch it over here, and we will be able to see that this function over here is the derivative of this one. But now we of course have the variable over here as x, and this is going to be 1, and this is 2 over here. So between 0 and 1, we have 2x. So it looks like this. Okay, 2x, this is 2, and this is 1. Okay. Now if x is 1, this is exactly 2, but now after this one, it's going to be a parabola. So we have something like this. When x is 2, you're going to have 5. So this is 3 and 4 and 5. So we have something like this. Okay, and this is g of x. This is g of x. Okay. And we can see that f of x, if we replace t by x, is exactly the derivative of this one. Okay.